Hi, let's do some more calculus. Whoop, whoop. We're going to do one more method of integration. This is by completing the square. So if I have something that looks like this and it doesn't look like u substitution or one of the other methods is going to work, I can complete the square. So you may or may not remember this from Algebra 2 way back when, but what we do is we're trying to make the denominator into something that looks like a quantity squared. And the reason why we're doing that is because all these problems are actually going to end up being something like arcsine, cosine, arctangent when I take the antiderivative. So this is way back in daily lessons 198 that you're going, or I'm sorry, not 198, just 98. This is almost 100 pages before this. So going way back to remembering arcsine, arccosine, arctangent. That's what we're going to need on this page. So here we've got 1 over x squared plus 4x plus 8 is not a perfect square. I can't say this is x plus something squared. So what I'm going to do is I'm going to take x squared plus 4x. I still have this plus 8, but I'm going to take this middle term, this 4, the b term, whatever's with x, divide it by 2, and I would get 4, or I'm sorry, divided by 2, I would get 2. Square it, and I would get 4. And you might be thinking, you can't just do that. You're right, I can't just do that. But it is okay for me to add 0. And so I did this, where I added 4 here, and then I subtracted it over here. So I'm really just adding 0 to the denominator, which is totally acceptable. So I took this expression, rewrote it as this. And you might be thinking, well, why would you do that? Let me keep going, follow along with me. Now we can write x squared plus 4x plus 4 as the quantity x plus 2 squared plus 8 minus 4 is 4. And you might be thinking, okay, great. Why'd you do that? That's because if I look back and we remember that the inverse tangent, and this actually has the chain rule in it, so we were just talking about the arctangent of x, we would say 1 over 1 plus x squared. That's what I'm seeing here, 1 over something plus x squared. But if I looked back to this, I had 1 plus u squared. So I still need to get this 4 out of here, so I'm going to manipulate this even more. What if I factored a 4 out of this expression? And actually, I'm going to write it over here. So if I factored a 4 out, 4 divided by 4 would be 1. I'm going to change these around in the same step. And then I would have the quantity x plus 2 squared. Sorry, I know that's really little, but it's just the quantity x plus 2 squared divided by 4. So if I distributed out, 4 times 1 would be 4. 4 times this whole quantity would be just x plus 2 squared. Okay, let me rewrite this a little bit nicer up here, so just so you can see where I'm going. I've got this integral, and now do you see how I have a 4 out in front, but it's 1/4? I'm just going to bring that in the front so it doesn't mess with me too much. Now I've got this quantity, 1 over 1 plus, see if this is x plus 2 squared over 4? Wouldn't that be the same thing as x plus 2 over 2 squared? If you're feeling like most of this is math magic, that's how I feel too. I feel like this is one of those problems that if you do it a couple times, you're like, oh, okay, I get it, but it seems sort of magical and that I'm allowed to do it. This is just a lot of manipulation with algebra. So some of you may love this because you like algebra, and some of you may hate it because you're like, why? I would never think to do this. You think to do it just as you see more and more examples like this. I at least want you to have exposure to this type of problem. Okay, so I have 1 plus this quantity squared, and now it looks a whole lot like arctangent. So this is where I'm taking, or I have an integral, which means I need to find the antiderivative. So I'm just going to write down 1/4. And if I know the derivative of arctan is u prime. This is like if I was doing the chain rule in some way. So this u prime is just the derivative of whatever this function is of u. I'm just going to say for right now, I'm just going to say 1. And then this quantity, instead of x, I'm sorry, I wrote this wrong. Hold on. I was going to rewrite this one more time, but I don't actually need to. I can actually skip to this step where if I'm integrating this whole thing, I have the 1/4. I know this is an arctangent sort of problem, but it's not arctangent at the x. I actually have a function in here. So I'm going to say this is arctan of 1/2 x plus 1. I can take this 1 divided by 2 and get 1/2, 2 divided by 2 and get 1. And the reason why I want to do this is just because if I were to guess and check this, and so now I'm going to take the derivative, I would say that I would have to do something with the chain rule. Wow. So I take the derivative, I can substitute in, but do you see how I'm going to get u prime right here? I need to take the derivative of the inside, so times 1/2. When I'm doing the antiderivative, if I want to just fix that problem, instead of multiplying by 1/2, what I'm going to do is divide by 1/2. Dividing by 1/2 is the same as multiplying by 2/1. So here I would get 2/4, or you could say 2/4 would be 1/2. Tangent, or inverse tangent, I'm sorry. Plus C. I really do feel like I should say ta-da here because it is pretty magical how I would get to that final answer. Let's do another one. And again, I realize that this is new and we're just getting into this. And really, we're not even going to spend too much time on it. It's just more like, I want you to know that this is out there. Let's do another one. So I'm going to go down to number 2 because this is a problem with the square root in it. You might think that looks even more confusing. With square roots, if I go back again to this daily lessons 98, and I see some things with square roots, that could be the sine or inverse cosine. And I'll just tell you in this one, there's not going to be a negative, so we're trying to get back to the arc sine as my original function. So this is definite integral, so it's actually going to be a number at the end. This is from -3 to -1. I know it's pretty light here. What I'm going to do is just start rewriting it the same way I did up here. I'm going to complete the square, but do so under the square root symbol. So I'm still going -3 to -1. I'll have 1/. And here I'm going to rearrange this a little bit. I'm going to take out a negative, but only of the x squared and the -6x. I've got a +7 out here. This all can just stay under the square root. So I rewrote this, so I switched around the order a little bit, +7. And the reason why I switched around the order is just, and took this negative out, factored out a negative, is because I want to complete the square, and I want to do so right here. So I've got -3 to -1, 1/. I would have negative. When you complete the square, 6 divided by 2 would be 3. Squared is 9. I would have +7, and you might say again, you can't just add a 9 if you don't subtract a 9 over here. What I actually did, so you see that this is a negative outside the parenthesis, and then I have a 9 here. What I actually did was I subtracted 9, so I need to add 9 out here. I'm going to rewrite this, manipulate it a little bit more. -3 to -1, 1/, square root. 9 plus 7 is 16, minus this quantity is x plus 3, that whole quantity squared. Now I'm getting it to something that's like this. This says u prime, but if this were just the derivative of inverse sine of x, this would only be 1/, square root of 1 minus x squared. So that's what I'm looking at, like 1 over square root of 1 minus something. Okay, I've got 16 here though. I want to get rid of the 16. So the way that I'm going to do that is factor out a 16. So I've got -3 to -1, 1 over, I'm factoring out a 16. So I'd be left with 1 minus x plus 3, this whole quantity squared, over 16. Because now I've got this 16, it's really like me saying 1 over the square root of 16 times the square root, because I have a product now, so I can do that. I can separate that square root out. 1 minus the quantity x plus 3 over 4 squared dx. Okay, let's keep going. We are so very, very close with just this part. I'm going to end up writing down here. 1 over square root of 16 would just be 1/4. I'm still evaluating from -3 to a -1. Now I've got square root of 1 minus, I'm going to rewrite this as 1/4 x plus 3/4 squared dx. Now this looks, you could do u substitution at this point, but I think that it takes a little bit longer. This is just pattern recognition and recognizing that you have something that will take me back to inverse sine. So this is my derivative on the inside. I need to go back. I'm carrying along the 1/4 for sine. And then I keep this stuff on the inside. Think about the chain rule backwards. So instead of wow, think about wobe. The stuff on the inside, I would multiply by it in the chain rule if I was taking the derivative. So I'm going to divide by it now. The derivative of the inside is 1/4. Instead of saying times 1/4, I'm going to divide by 1/4, which is the same as 4 over 1. In a typical problem, I would say plus c, and I would be done. But this one was a definite integral from -3 to -1. Fundamental theorem of calculus says I can do f of b minus f of a. So this would be the inverse sine. I'm substituting in -1 first because it's the f of b, it's the higher one value. 1/4 times -1 would be -1/4 plus 3/4 would be positive 2/4, also known as 1/2. If I substitute in -3, -3 times 1/4 would be -3/4 plus 3/4, I get 0. Now remember what inverse sine is. That's the same as saying sine of y is equal to x. I'm taking over this space. I'll have to get another piece of paper for this one. But the inverse sine of y, or I'm sorry, the inverse sine is the same as saying sine of y is equal to x. So I need to think of what would equal 1/2, like the sine of what would equal 1/2, and that would give me my function value here. And I think, and you might even be thinking, well, hold on, if I have pi over 6, this is pi over 3, this would be something, a triangle that would give me 1/2 would be pi over 6. So sine of pi over 6 was 1/2. So in this case, the arc sine of 1/2 is pi over 6. If I want 0, thinking about a sine curve, sine of 0 is 0. Whew. I get pi over 6. Don't stress about this. It takes some time, but if you were like thinking about, do I need to know this, or do I need to know what it means when I'm integrating, like what the units would be, what it actually means to do a Riemann sum, focus on that stuff. If that's where you're at, or if you're like, I'm good with all of that, that seems pretty easy to me, then go to this material and think, okay, I'm going to try this. I'm going to give it an honest effort. As always, if you need anything at all, please let me know. I appreciate you learning. I appreciate you working. Try the other ones, compare with my answers, see what you get. Thanks so much for being great. I appreciate you. Bye.